Dear students, welcome to the math session. Today we are going to discuss the topic of sets. As you can see that on the left hand side of this screen, there are some points which we are going to cover today, include set definition, how to represent a set, what do we mean by element of a set, the Venn diagrams, what is a subset, universal set, and then there are some different operations we can perform on sets. So let's start. So by definition, set is a collection of clear and different objects. So these 2 points are important, clear and different. So the collection is called a set if each and every element of that collection should be different from one another. Now these objects which are part of the sets are also known as elements of sets. Element of a set. So objects or elements basically represent the same thing. For example, let us write down some collections. A, B, C, D. Let us write another collection, 1, 2, 3, 4, 5. And let us write down a third one, 1, 2, 3, 3, 4, and 5. And if we enclosed these collections into parentheses, brackets, and give certain names to them, then these may be called sets. So set X is equal to A, B, C, D. So set X has 4 elements, which are A, B, C, and D. Similarly, set Y has 5 elements, which are 1, 2, 3, 4, and 5. And set Z has also a certain number of elements. Now, by definition, if you see in set X, all these 4 elements are very clear. They are English alphabets, first 4 English alphabets, and they're all different from one another. Similarly, in set Y, we have a clear collection of different objects. These are the first 5 natural numbers. While in set Z, we have some numbers, but you can see that there is a repeated number. So there is a repetition. So element of this sets are not different from one another. At least there is one element which is the same to another one. So 3 and 3 are the same. So this set Z basically does not fulfill the definition of set. So it is not a set, right? So this is not a set. This is a set. This is a set, because both of these fulfill the definition of set. Now, as I said that the objects inside the sets are known as elements of set, and this is the symbol we normally use to represent elements. So if I want to write it down that whether A and this symbol X, so it means that A is an element of set X. 4 is an element of set Y. But if I write here, E is not an element of set X. So if you put a line on that or cross it, it means a certain object is not an element of a certain set. Okay? Now, another thing is how to represent set. One way you already have seen that if I have a set X and it is 1, 2, 3, 4. So there are 4 elements. This is the major form of set which we actually normally use to describe a set. But you can also use it like a descriptive form. I mean, a simple definition, what the elements of sets are. So you can write down definition, for example, X is equal to set of first 4 natural number. Right? Or you can also write it down in symbolic form. X, we just define a variable. It can be X, it can be Y, it can be Z, it can be A, B, C, any variable. X such that X is a natural number. And X is less or equal to 4. So these are the first 4 natural number we are talking about. Similarly, the set Y was, for example, let us define the set A, B, C, D, E. So what is this? If you want to describe it, set Y is basically a set of first 5 English alphabets, right? So this way we can describe or write the set using different notation, but in general, this is the main notation which we are going to use. Then there is a very important topic known as Venn diagram. So Venn diagram is another way of describing a set. Venn diagram is nothing but a circle which contains the element of a certain set, and then you name it at the top here. So this is Venn diagram. When we will discuss the operations on set, then Venn diagrams are very, very important. They make our life very easy when we actually come to tackle the problems related to set. Now, another definition here is subset and universal set. We'll quickly go through these two as well. Subset. Let us consider two sets. There's a set A, and this set has some elements 1, 2, 3, 4, 5. Let us consider another set B, and it contains the element say 1, 2, 3. Let us consider another set C, 3, 4, 5, and another set D is equal to 7 and 8. So these are few sets I have just taken as an example. If you see the elements of set B, 1, 2, and 3, these elements are present in set A. So basically, the element of set B are taken from elements of set A. So in this case, B is basically taken out of A. B is part of A, whatever you want to say it. So because B, the element of B, all the elements of B are part of set A, therefore set B is a subset of set A, right? Similarly, if you look into the elements of set C, 3, 4, 5, they are also taken out from set A. So therefore, C is also a subset of set A. This is the symbol of subset. Okay, it is a symbol which resembles like a less than symbol. I mean, less than symbol is like this, and subset is like that. Okay. So B is a subset of A, and C is also a subset of A. But if you look into D, even though D is a very small set, it only contains 2 numbers, but none of these numbers exist in set A. So even though D is smaller than A, but it doesn't mean that it is a subset of A. So because the elements of D are not the part of set A. Okay, so therefore D is not a subset of A. All right. So universal set and set operations we will cover in the second video.